Hello, everyone, and welcome to 5 common mistakes while preparing for silver and how to fix them. I forgot to add the how to fix them or avoid them in the title, but yes, we are definitely going over the 5 most common mistakes and how to fix them. All right, let's get straight into it. So, first of all, first mistake number one, learning concepts at a high level. What I mean by that is, let's say you know the different base concepts, like you know binary search, prefix sums, DFS, BFS, all the different base concepts for silver, but you cannot apply them to hard level problems. So you cannot apply, say, I don't know, like prefix sum to a difficult prefix sum problem, or binary search, or floodful, whatever that concept is. That is one of the first common mistakes. So how do we fix this? Instead of learning the concepts at a high level, just sort of understand that, like, let's say that silver was just about learning these concepts at a high level. Literally just read an article, takes less than 30 minutes, and you can learn each concept in under 30 minutes at a high level, right? If that was the case, then everyone would pass silver and make gold, and there would be no competition. So the reason that silver is a competition and the reason that it's impactful is because learning algorithms at a super high level is not going to be sufficient. Um, so what do we have to do instead? Well, essentially, you want to get super in-depth into every single algorithm specifically for USACO. So you have an in-depth understanding for every single algorithm, like, hey, here's the criteria of when to use the algorithm, right? Sometimes even identifying which algorithm corresponds with each problem can be difficult for some people. So here's the criteria of when to use the algorithm. Then here are the steps to use the algorithm to solve the problem. Then here are the steps to use the algorithm to implement it. And just having those crystal clear structures in your head allows you to think clearly about the problem, and it allows you to generalize it to more complicated problems. Right, sometimes for easy problems using an algorithm, I mean, you can do that without much preparation, you can do that without much finesse. But to get to really, really complicated problems within an algorithm, you're going to need to have a super in-depth understanding. And just having those clear steps allows you to like have a framework that you can just get better and better at to solve harder and harder problems, rather than just like thinking really hard or trying to think really hard about these problems, and that works really easy, but that cannot be scaled up. So you want to make sure you're working on things that can be scaled up, and frameworks like this definitely can be. All right, step two. This sort of ties kind of into step one, which is just sitting and thinking. What do I mean by that? Again, not everybody, but some people in silver. Like, all right, I'm working on this problem, thinking about it, thinking, fully thinking, and I hope the solution comes to my head. And this sort of runs into a similar problem of the previous thing we were talking about, right? So we sit and think about it. So let's just say we have an in-depth understanding of the different algorithms. We still have to make observations. We still have to use our problem-solving skills to simplify the problem down to the point where the algorithm can even be used in the first place. So what does this mean? That if we're just sitting and thinking, as you might imagine, that's a very passive way of approaching problems. Now, where does it come from? Well, let's say that you're just working in a math class in school. How do we prepare for exams? Well, we're going to solve a bunch of practice problems, usually on the homework, and might even practice them ourselves, similar to the ones that'll show up in the exam, and then we'll just get the ones in the exam right, because we've solved similar ones in practice. So in the exam, we sit and think, and our brain recalls similar stuff we've done before. It tells us how to do it, and we solve the same problem. Great. Now we try to apply that to USACO, but we realize it doesn't generalize. We realize pretty quick, for bronze, the easier ones, even medium ones, it works. For the hard ones, it starts to get difficult. Some people can get lucky or they can get through it for the hard bronze problems, but for silver, you definitely can't get through easy, medium, and hard with that, with just sitting and thinking. So it comes from the thing of like when people prepare, what they do is they read the problem. If they get stuck, they read the solution, understand it, and move on. So they fully understand those observations. But the problem is those same observations are not showing up repeatedly. They're not showing up on future problems. They're not showing up in contest. And so what that means is that you spend all this time and you only get like a small amount of growth out of it, which is bad. So instead, what do we want to do instead? Well, we want to focus on problem solving skills instead. And these are the steps that you take to make observations. Like, what are we going to do to make observations? Right? And, part of it is like, First of all, just doing stuff rather than being passive. And then another part of it is then to work smart about it. Learn the specific problem-solving skills I show repeatedly in Silver. So when you miss a problem, instead of focusing on the observations, now you can focus on the problem-solving skills that you missed and get stronger and stronger at the problem-solving skills to be able to solve harder and harder problems. Because the problem-solving skills will generalize in between problems, right? As you work on problem-solving skills, I'm not going to name names of specific previous students I've worked with just for their anonymity. You can see some of the ones who do release their names on the website as testimonials, but I've had multiple students who are like, they're struggling with the problem and they're struggling with making progress. We're trying to working together. And it's this exact problem where they're just not learning the problem solving skills. Even if they're not just borderline thinking, they're still focusing on observations rather than problem solving skills. So they're progressing like this, but then once we make those changes, once we help them focus on problem solving skills, they're shooting shoot up. And you can see like perfect scores in 4 weeks. Like when you see that, this is usually what the shift is. All right, the third mistake. Oh, I'd written the third mistake down as not learning problem solving skills. So I guess we already covered that. So I guess what I meant to do with sitting and thinking was just like be active instead of passive and then problem solving skills. So sorry about that. We've already gone through that one. But anyways, all right. The fourth mistake. Okay, this comes down to coding language. So for bronze, Python is effective. The 3 languages for USACO are Python, C++, Java. So for bronze, you can use any of the 3. For silver, Python starts to cause some problems. And by the time you get to gold and platinum, Python's really causing a lot of problems. So my recommended language for USACO is C++. That being said, Java works just fine too. The people who get into camp using Java. C++ gives you a little bit of an advantage in terms of runtime, but you can make things work with Java. Just a little bit more difficult, but not that bad at all. Like it's very doable. However, I have not seen anyone make it to USACO camp using Python. Doesn't mean they don't know Python. They know it. They just haven't solved platinum problems with it. And so then you scale down to like, are there people doing gold and advancing to platinum with Python? Now, this is going to be impossible to know. But in general, I would say it's very, very unlikely. In silver to gold, you'll be able to solve quite a few problems with Python, but you're going to get stuck on a lot of them. To the point where you're going to need to be significantly better to succeed in Python. Because you might miss easy problems because of using Python. So you might need to get the hard problems. Maybe some contests it'll be impossible and some contests will be possible. So some amount of luck plays into it too. Personally, I don't like relying on luck. I like being like, all right, I did everything I can to prepare for the contest. And doing everything you can to prepare for the contest involves learning either C++ or Java. Now, in terms of language, a lot of people like to learn Java because APCS in school has it. Like, all right, if you want to do that, fine. But Java for APCS is very different than USACO. There's a little bit of overlap, but a lot of the complicated stuff you can just easily learn in the class. I recommend C++, but if you want to do Java, that works as well. All right, fifth mistake. And this is a killer. Like when I see someone who seems to be doing the right things but is unable to advance, it's normally this fifth thing. It's not having your heart in it. And this may seem very cliche, but give me a chance to explain real quick. So for bronze, you can sort of just bash through, be pushed by your parents, and advance to silver. For silver to gold, it's not just about putting the hours in, it's about putting the hours in at a high quality, right? Actually spending time working on problem solving skills, actually spending tons of time working on a singular problem. Now, if instead of spending 40 minutes thinking about a problem, you just spend 5 and read the solution, guess what? You can spend a lot of time, you can do all the quote unquote right things, you're not going to make the progress. If instead of focusing on problem solving skills, you just read the solution, you don't even bother learning them, again, you're going to cause the exact same thing where you're just not making the progress. And why would you do these things? Why would you not spend time learning problem solving skills? Why would you spend fewer times working on a problem before you read the solution? Because your heart's not in it. That's the main reason usually. I mean, I don't want to say always, stuff happens, but normally, if your heart's not in it, it's very difficult to make any success. So make sure that you're passionate about USACO. And if that means that you don't code 8 hours a day, 5 days a week, or 7 days a week, you're not coding 8 hours a day, 7 days a week, all good, right? Make sure the rate you're working on USACO in is enough to make progress, but still at a point where you're maintaining passion. Now, me personally, I was able to work like 6 to 8 hours a day on USACO every day. and so passionate about it. I was really happy, especially like over summer. Over the school year, like 2 hours on weekdays, 6 hours on weekends, but over summer, I just work all the time. And I was super happy and passionate about it. Apologies, I still have a bit of a cough. But anyways, I was able to do all that and still be passionate about it. So it worked out for me. But if for you, that means that like, hey, I need to take a day off of coding so that I can like rejuvenate my passion, right? Separation increases passion. That's just that's been my observation. That seems to be the stuff of like quotes where it's like, this just makes the heart go fonder or whatever. Whatever you want to call it, the reality is you need to have a passion for USACO. And if you don't, if you're like, hey, I want to advance to gold, but you're not passionate about the day-to-day of USACO, it's going to be insanely difficult for you. There's nothing wrong with the goal of like, I want to advance to gold, platinum camp. Those are great goals. Even IOI, amazing goals. Right, IOI, EGY camp, whatever that is for you. Cool. Even if it's just gold, great. Nothing wrong with those goals, as long as you also have passionate for the stuff that you have to do in a day-to-day. Because if you don't have passion for stuff you have to do in the day-to-day, it's going to be very difficult. And even if you do somehow manage to get to gold to platinum without passion is nearly impossible. I will say that. All right, those are the 5 most common mistakes people have when preparing for silver. Just to recap them for you real quick. 1 is learning contests at a high learning concepts at a high level instead of in depth. So again, you want to go super in depth. Criteria of when to use them, steps to solve a problem, steps to implement. Right, one able to solve hard problems with an algorithm, not just the basic ones. Having that flow helps us scale up to harder problems rather than just thinking and just stuck with easy ones. 2nd is sitting and thinking. Again, sitting and thinking and hoping the solution comes to you, not very scalable. What's going to be a lot more scalable is active problem solving and taking steps. Number 3, not learning problem solving skills. Okay, it's going to be a lot more. You're going to weight problem skills from here to here. We start focusing on problem solving skills instead of just what the solution are. Number 4, trying to code in Python. Again, it's possible to advance with this, but you're leaving stuff to chance and you have to be significantly better. So recommend C++ or Java. And number 5, not having your heart in it. Honestly, life is short as well. Do what you actually find passionate, and you're going to have a lot more success. Because I understand you might have these big goals, but if you're not enjoying the day-to-day, it's going to be a drag on you, and you're going to get burnt out as well if you're not passionate. All right, so those were the 5 tips, and we just summarized them real quick just so that you were reminded of them in case you missed something as well. If you have any questions, put them in the chat, and I'll get to them in a second. All right, cool. Well, I'm not seeing any questions, so that's it for today's training. Today was more like back to the concept style. Next week we'll go back to more of like a tactical thing that we're working on. So yeah. All right, have a wonderful day and see you guys next week. Bye. I see a question coming in. Sorry for that question, but how would you recommend we solve problems instead of just sitting there and thinking of them? So, Anshul, I would focus on problem solving skills there. So the first, and like I'll give you 2 simple ones to just sort of chew on right now, right? One is going to be drawing test cases. So try to draw like 6 to 7 test cases of size n equals 6 to 7. And you don't want all of these test cases to be identical. What I mean by that is, like, obviously you're not going to be identical, but like if you don't just want to have random numbers for all of them. You want all of them to like test something interesting about the problem. Like what happens in this interesting case. So for example, try to make a test case where the answer is 0. Or try to make a test case where there is no answer. Or if it's a graph problem, try to make a graph where it's a tree. Right? Or try to make a graph where it's a straight line. So just trying weird things in these test cases that you're doing. And the second thing I'll give to you to sort of chew on, I think there's a bunch of problems. I'll try to give you the second one here. This is going to be asking yourself questions to simplify the problem down. So given a problem, maybe you like ask the question like, all right, instead of having n cows, what if we just had 2 cows? Or instead of having this entire graph, what if we had like a star where everything comes out? Or instead of having this tree, what if we had a binary tree where every node had 2 children? So the criteria of a good question is it should be a sub-question such that if you solve the entire problem, you solve this question. And on top of that, it shouldn't be something trivial that you answer immediately. So it should be like something that you can actually chew on. And the goal of the sub question is that when you answer them, hopefully you'll get an observation. You can also combine the two and you can like draw test cases to answer your sub question. That's also an option. Again, these are just two. You can have like the whole, I believe we have like 10 or 12 in the course, so you can sort of chew on and mix and match them. But these are sort of two to get you started. One thing I will add is don't expect that you ask the first question and it's a perfect one. Right? When I'm solving problems, I might ask like 6 or 7 questions until I get to something that's like good. Some might be too easy, I just instantly have an answer. Some might be too hard. Even when drawing test cases, I'll just keep going. I'll keep drawing like 10, 12 test cases until I like notice something interesting about it. And even draw test cases to answer my sub questions. So I hope this answers your question of what can we actually do. It's again applying problem solving strategy. Those are just two to get you started, but there's a bunch more that should like it's just what steps should you take to arrive at the solution? And that's essentially what we're working on. Does that answer your question? Perfect. All right, cool. Any other questions? All right, wonderful. There's no more questions, then yeah, I'll see you guys next week and we'll do more of a coding thing next week. A little more coding and then micromechanisms conceptual in a couple weeks. All right, have a nice day. Bye.